Okay, so we're recording. So later you're going to see that this information is up on the internet. Okay, so characteristics, natural numbers. So what we're talking about with natural numbers is numbers that are natural to caveman, because caveman wasn't very smart. So he started counting, right? He said 1 rock, he said 2 rock, he said 3 rock. So the natural numbers are basically our counting numbers. And it started at 1, and then 2, and then 3. He couldn't split anything up. Caveman wasn't that smart. But then later, caveman started getting a little bit smarter, and so for whole numbers, these are going to be 0. He decided, hey, if I get rid of all my rocks, I have 0. So it's going to be 0 plus the counting numbers. Okay, he still couldn't split things in half or 3/4, so he couldn't do decimals or fractions. Okay, but he was smart enough to realize that you could have 0. So we started with 0. Our number system got a whole bunch more complex. But then, caveman, he said, you know what? He started betting. And so he kind of bet, 3 rocks on a horse, and he lost it. But the problem was he didn't have 3 rocks. So he actually owed someone rocks. So what happened is they started saying, you know what? If you owe money, or rocks, then we're going to have negative amounts. So for integers, they're positive, they're whole numbers, but they're positive or negative whole numbers. Plus 0, because he understood 0 part. He was smart enough to get that. So he could start at like -4, -3. Of course, bigger numbers if he is a big bettor and he bet a lot of money. And then, of course, he got bigger too, because if you win, well, then you win big. But guess what? He still didn't get anything about decimals. He didn't know how to split things up. So there are still no decimals for integers.
Teachers, please excuse this interruption. Grade 12 students with the last names N to Z, with teacher permission, can come down to the counseling center at this time for a course change.
Not only was that no decimals, but also no fractions. Okay, so he didn't understand that you could, a fraction is a half of things too, right? Half of a whole, or a part of a whole. Okay, and so what happened is all these are rational numbers. Okay, so rational numbers can be simplified. So our rational numbers, oops, sorry, I'm going to take that off. Our rational numbers are simplified. I'll even write that here. And so there's a couple definitions of those. Our rational numbers are everything above is rational, okay, as well as decimals. So our rational numbers are decimals that stop, so it's like 1.2, 1.4, or repeat. Now that's kind of what I use to test whether it's a rational. The other definition, the true definition, is that you can make a fraction out of it. Now, if I have, say, the number 6, that's not a fraction, so is that a rational number? Well, what's the decimal behind it? 6.0, right? So it's totally rational. How is that a fraction then? What is that as a fraction? 6/1. Okay, so you have to know how to turn things into fractions. So then often, we look at 0.5. What is that as a fraction? Well, it's 5/10, which is 1/2. So it's simplified. And we have negative numbers in there as well. You can make all your negatives fractions as well. So like -13. Okay. 2/3. Is that a fraction? Definitely is. But what is that as a decimal? 0.6 Repeating. This is an interesting one. Try this on your calculator. If you have a calculator here, I'll pull it up. Where's mine? So to turn a fraction like 2/3 into a decimal, I simply go 2 divided by 3, top number divided by the bottom. Uh-oh, I got a problem. What's my calculator telling me at the very end? It's 7. How many people's calculators have a 7? Hands up. How many people's calculators don't have a 7? Yeah, quite a few. It's about 50-50. What's my calculator doing? Rounding. So you gotta be smarter than the calculator, okay? Don't think, oh, it's not repeating because the number has changed. It's still repeating, they just rounded it. Okay, so just be aware of that. Sometimes your calculator is going to round the last digit, but it's still repeating, and it is a fraction. So if you can make it a fraction, it's a rational number. What about something like square root 100? Well, first of all, you got to simplify it. Yeah, this equals 10. Can you make 10 a fraction? Absolutely. You can make that 10 over 1. Okay, so a lot of the numbers that you know are all rational numbers. But what we are going to look at now is we're going to look at irrational numbers. So irrational numbers, you cannot make a fraction. Now what they often say is the fraction is 2 letters, a over b. Don't be too worried about the fraction a over b. It's just math jargon. Okay, now they say that b cannot be 0. Okay, that's the other math jargon. So they say that b cannot equal, that's what that little symbol is, an equal sign with a line through it. B cannot equal 0. Because if 0 is in the bottom of a fraction, it's a math error. Okay, you can't divide anything by 0. You can't take 3 sheep and divide into 0 groups. Unless you're Harry Potter and can make it disappear. Okay, it's a little young for you, sorry. Okay, next. Some irrational numbers. Oh, I don't know. What am I supposed to do here? Yeah, whatever. Don't show this message again. Okay, some irrational numbers are like square root 3. We actually call this a radical. Okay, you're going to see that term come up again. I just want to talk about it. It's a radical. It's root 3. Try that on your calculator and see if the decimal ever stops or starts repeating. So for me, I got to go square root button, and then 3, and then equals. Okay, so I get this like 1.732050808. On this calculator, I think I have to do 3 and then square root button. Okay, so you have to know how to use your calculator. Older ones, you type it in backwards. Newer ones, if you actually see your square root symbol, so if you press that button and you actually see that on your screen, you enter in square root 3 as you see it. Okay. But this calculator is a bit older. Now this one, look at all those decimals. Anything repeating? No. That's why it's irrational. It never stops. It actually goes on forever and ever and ever and ever and ever and ever and ever. What about square root 6? What do you think? Can you do square root 6? Try it on your calculator if you got one. If you don't, have a look up here. Whoops, what do I do here? Yeah, clear. 6 square root. I have an old calculator, so I have to do it backwards. Look at that, huge. Goes on forever and ever, ever. No repeating. No repeating. Okay, so that's irrational. So you can also say these, right? That's what I'm talking about. Rational numbers can be simplified. Square root 64, what does that equal? Try it on your calculator. If you don't have one, look at mine. Again, it's old school, so I have to do it backwards. You know, 8 square root. Sorry, what am I doing? Idiot. 64 square root 8. Right? It stops. It's simplified. So if you can simplify it like it's a perfect square, then it's rational. Otherwise, irrational. Any questions? What about this? Pi. They love checking pi. Press the pi button on your calculator. You should know where it is from doing circles. Where is mine? Do I not have a pi button? Oh, here we go. Pi right there. Goes on forever. Right? They even have supercomputers trying to calculate the end of it. Haven't done it yet. Okay. Any questions so far? Okay. The big thing that we focus on is, the first step, get a general idea of what we're talking about. Okay. But what we're going to really look at is the difference between those two, rational and irrational. Okay. And we usually look at your square root signs. Can you simplify it, or can you not simplify it? Okay. Decimal does not stop. So if you're looking at your calculator, decimal doesn't stop or repeat. Now, real numbers, those are both rational and irrational numbers. So those are all the numbers all the math you've done so far, those are with real numbers. If you're going to make something crazy up, then it's not real because you just made it up. But everything it's a real number. Okay. So we have a little diagram to help you out with trying to memorize all this stuff. This diagram here, with the big box, everything inside is a real number. Okay. So what we have, though, is we have irrational numbers on the outside of the circles. They do, okay. Sometimes in math, you'll see an R with an apostrophe. So that's an R, we call it, sorry, not R with an apostrophe. It's a Q with apostrophe. It stands for Q crazy, because it's irrational. Whereas our rational numbers would just be a Q. So we have Q and Q crazy. You might see it, probably won't, okay? So that's a little bit more than what you need to know. Now, rational numbers, they started with what numbers? Who started our number system? Caveman, right? So he starts with the natural numbers, anything that you can count. And then we started to develop zero, and we had our whole numbers, okay? Then after whole numbers, we got more complex. Caveman started to bet, and what did he invent? Integers. Okay, those are positive and negative whole numbers. Now you got to remember the difference is no decimals. Okay, so these are positive / negative whole numbers. But then for our rationals, then we start to get into anything that could be a fraction. Right? And of course, fractions we turn into decimals. So they're not giving any special name. We just call them rational numbers. Okay. So thinking those definitions just by inspection and playing with your calculator, do whatever you'd like. Number 5, I'd like you to try and do without a calculator if you can. Just test some knowledge. Tell me whether it's rational by writing the letter R, or tell me if it's irrational by writing the letter I. You can work with the person beside you or work on your own and then compare answers, whatever you like. Okay, how about you work on your own real quick and try comparing answers. Most of this won't be calculator work, okay? But number 3 would be calculator. Go for it. Give you 2 minutes. Yeah, Kathy? Yeah, I'll do all 6, please. Okay, so just do all 6. So check your definitions up above. A lot of confusion, sorry about that. That's right, I gotta pause this stuff. Okay, so this first one is actually rational because you could put the repeat bar over the last two digits. Okay, this is showing that it continues forever. Okay, the dot, dot, dot. Okay. Number 2. OT, what do you think? Why? There's pattern. Exactly, great answer. So the pattern is that you're increasing, right, by a 3 each time, but it's not repeating. So it's irrational. It's not repeating. Okay? They always like to throw you that trick just to see if you're paying attention. Okay? There's a difference between pattern and repeating. Different words, different meanings. Number 3. Lori, what do you think? Irrational? Yeah. So if you got one like that, first of all, this is not perfect. Right? It's not a Mr. Barker number. It's not perfect. So it's going to be irrational. But who can give me an example? What can I change that 3 to make this a rational number? Any ideas? What can you change that 3 to, and then this would be a completely different answer? 4? Yeah, definitely. Right? 4, what would be the next number? No, 6 is still not perfect. 9, right? Because 9 is square root of 9. So what we're looking at here is this, folks. Square root 4 divided by 2 equals 2 divided by 2. Right? So that's what I'm talking about here, is this is not a perfect square. And so this simplifies to 1, which is a fraction, 1 over 1. Okay? Messing with your minds a little bit. Okay? And so the next perfect square is square root 9, because that is 3 over 2, and that's a fraction, so that would both be rationals. Okay, so these ones were same type of question, but rational numbers, whereas the example we had, square root 3 is irrational. Okay, next one. What do you think? Jaspreet. Rational? Why? What's repeating? Good. Okay. So it takes us a while to get there, but eventually we do. So we can write the number like this. So it is a rational number. Okay. So number 1's rational. Number 2 is irrational. 3 irrational. 4 is rational. What about number 5? First of all, change it to this. What would go on top if I want to convert that to an improper fraction? 9, yeah. 2 times 4 equals 8, plus the 1 that's there, so that equals 9. Now remember from last year, your teacher should have talked about this. That's the same as square root 9 over square root 4. So you can take your square root sign and square root the top and the bottom. And if you do that, what are you going to get? 3 over 2. So it's definitely a rational number, a fraction. Okay? It looks big and complicated, and you must convert it first. Okay? You absolutely must convert it first. Okay, we're going to do a fair amount of that stuff. What's square root 200? What two numbers multiply with 200? They're the same? I don't know. Try it on my calculator just to be certain. I don't think there is a perfect square. That's right. It's not perfect. Okay? And so this is going to be an irrational number. It will go on forever and ever and ever. Okay. Any questions? All right. So let's just change over then. Introduction to radicals. So what we have here real quick, this is called our index. So often if we don't write it, which we hardly ever do, what's our index? We never write it. It's got to be squared, a 2. So the index is 2. We're looking for two numbers that are identical. So for example, square root 49 equals square root 7 times 7, which equals 7. So the index is a 2. It's saying what two numbers multiply to 49. The x, we call that the radicand. So that's a weird number. It's a word, sorry. Okay, so the inside number is the radicand. The outside index is the n. Now sometimes you get an index of 3. So for example, 2 cubed equals 27. So then, cube root 27? Well, I can break that down into cube root 2 times 2 times 2. So now the index is saying, how many groups of 3 do you have? Or sorry, what's the group of 3? It's a 2. So now don't be too worried about all this stuff. I'm just throwing a lot of information at you. Okay? We have indexes of 4 and 5. So look at groups of 4 and groups of 5. We're going to come back to this stuff in a couple of days. Just introducing it to you right now. Okay, hitting you through quite a bit of vocab. All right? Any questions you guys have? All right, let's go on then. Now we just talked about rational and irrational. So radicals can be rational if they're perfect. So for example, square root 16 equals 4. Or cube root, what's another perfect cube? What's 3 times 3 times 3? 27? Whoa, folks. You should have said something. Okay, should have said something. I made a mistake. Please correct this in your notes. Always interrupt me, folks. Okay? Always interrupt me. Let me know what I'm doing if I'm doing stuff wrong. I do make mistakes. Lots of them. As you guys know from last year that I had, right? Danelle's nodding her head and laughing. Yeah, thanks, Danelle. I'll remember that. Anytime. Okay. Good. So cube root, let's go 4 times 4 times 4. What's that? 4 times 4 is 16 times 4, 64, right? Okay. And so that equals 4 as well. Now we're going to do a lot of these. We're not going to get some crazy hard numbers. We usually go to like, 100, 100, stuff like that. Okay. Now irrational, that means it's not a perfect square. Okay, so it's not perfect. So you can't remove the sign. So it stays as like square root something, square root 3. Right? You can't fix that. Then it's irrational. Okay. So how do you know a radical will be rational? You have to look for the perfect sign. So you're going to have to kind of memorize or check on the calculator. Which brings me up a good point. Do you guys understand that there's a non-calculator section to your provincial exam and a calculator section? So there's 2 parts. Even this unit test, there's 2 parts. Okay. Now in the non-calc, it's simple stuff. Okay, it's not like crazy hard, super complex calculations. It's thinking stuff. Okay, so don't be too concerned about that. Next, evaluate the radicals. Okay, square root 25. What is that one? So evaluate means simplify. Tell me the answer. I'm looking for a number. Okay, square root 25, it's 5. What about this one? Now, I can simplify that to square root 5 times 5, which equals 5. This one, cube root negative 64, that would be a negative 4 times a negative 4 times a negative 4. So what number is occurring 3 times? -4. Okay, now that works out really good because the index is an odd number. Okay. So it's an odd index. What about cube root of 8? What could you change the 8 into? Play around with some stuff. What 3 numbers are the same? Start low. 1 times 1 times 1? No. 2 times 2 times 2? Yeah, nodding your heads. So you'd rewrite that as 2 times 2 times 2. And so the cube root of 8 is simply 2. Ooh, what about this one? 6 root of 64. Hint. It's a number that has to multiply by itself 6 times, but only gets to like 64, which is a small number. So if you're thinking like 5 times 5 times 5 times 5, man, that's going to be huge, right? Because 5 times 5 is already 25. Multiply one more time, and you're at 125. Right? 5 quarters, 125. So it's got to be a number less than 5. Any ideas? Guesses? 2, exactly. Okay. So just to show you this whole idea and whole concept, this is going to be 6 root of 2 times 2. Now sometimes I use a multiplication sign, sometimes I use a multiplication dot. Okay, it's not a decimal, it's up high, it's a multiplication dot. And so that simply equals 2. Okay. Next one, any ideas? Okay, so now we're going to do some, this is a calculator question. Okay, so how you do this on your calculator depends on the calculator you have. Most of you are going to have to go 5, hit your second function button, hit this button here with an X in it, then press 3, 1, 2, 5, then press equals. Okay. So I want you to play around with that and try that. You should get 5 as your answer. How many people got that? Yeah. If you have an old school calculator like mine, I would simply enter the radicand first, the inside part, and then I have to press this button. Now this one has a Y for the index. There we go. Okay, it's a little bit different. We'll go more into calculator stuff in a second, okay? If anyone having troubles with the calculators? You? Bring it up real quick. Try number 9. Try number 4. Oh yeah, yours is a little bit different for sure. Okay, so it's going to be this button here, shift. Okay, so you see I did blank boxes. So let's try 5, shift here. Okay, so now, okay, so what you got to do here, oh wow, delete. So once you press that button, that goes up here, then you got to get into your boxes. Okay, so now you're in the top box, you can press 5, go in the bottom box, 3, 1, 2, 5. Now it looks exactly what it's supposed to, okay? There you go. Okay, so for number 9, guess what, folks? This 9 times 9. I just expanded that, and so my answer is simply 9. These two cancel out. All right. So we're talking about that in a little bit too. What about 3600? Square root 3600. So what we can do, since there's 2 zeros, right, what's square root 36 equal? 6. So square root 3600 is going to be 60. Now another way I can look at this is I can go square root 36 times 100. This is above you. 36 times square root 100. 6 times 10 equals 60. Just playing with the numbers, rearranging things. Okay. Again, we don't get into that too much. Try number 10. See what you think the answer is. Now there's 4 zeros. You guys know what the fourth root of 81 is? Okay, it's 3. Okay. And so the answer then is 300. Okay. Oh no, sorry, 30. It was fourth root. Is that right? 30 times 30 times 30 times 30? Okay. Okay, what about this one? Square root of 81. So we looked at this one last year. So what's 0.81 as a fraction? 81 100ths is 81 over 100. So that equals square root 81 over square root 100, 9 over 10. Okay. Okay, I'll just get a little bit crazy. What about number 6 though? Any ideas? As a decimal, that would be 0.9. So this would be 0.07. Okay. So you could try that on your calculator as well. All right. So this is a standard test question. Without the use of the calculator, estimate, okay, place these numbers in the appropriate location on the number line. So which one's higher, which one's lower? First of all, let's set up 0 right here. Okay. So we have a place for 0. Actually, check that. Let's just wait and see what we got. So 2 root 8. I don't want to do this with you yet. Okay. So what I want you to do, let's just stop right there. So for estimating, let's turn back to our notes here. What a couple things. Number one, A is going to be above you a little bit. But what we're going to look at here for A is you got to take the 2 and bring it back inside. So what we're going to do is we're going to write this for A as square root 2 times 2 times 8. So if you have the number on the outside, when you bring it inside, you're going to have to do the opposite square rooting. You're going to have to square it. So 2 times 2 is 4, and then 4 times 8 is 32. Okay. So you'll notice that A and C are exactly the same. Okay. Now there's other ways of doing this as well. However, you want to estimate their size. So last year we looked at having a perfect square below and a perfect square above. So thinking about, 4 squared is 16, 5 squared is 25. So the next perfect square below it is 25. That equals 5. What's the next perfect square that's above it? 36. Okay. And what does 36 equal? 6. You kind of get the idea that's 6 and 5 are 1 apart. So there's got to be some decimals in between there. So what's the approximate value of square root 32? Well, what are you closer to? Are you closer to 5 or closer to 6? Yeah, a lot closer to the 6. So here we look at the distance. How many digits away is 32 and 6? There's 4, right? There's a difference of 4 digits. What about 25 to 32? What's the difference between those two? 7. So yeah, we're a lot closer to the 6. We're only 4 digits away from this. Okay, we're only 4 digits away. So if we were in the middle, we'd say 5.5, but that's not right. Okay, it's not 5.5. Okay, we're closer to the 6. So I'd say, what would you guess? 5.7? 5.8? Yeah, I'd probably say 5.7. Okay. 5.9 is 100% wrong, and I'd say 5.6 is 100% wrong too. Okay. Try the calculator, see what we got. Okay. 32 square root, 5.65. Okay. So 5.6 is wrong because we're closer to 5.7. Again, it's just estimation.
Please excuse the interruption. Would grade 12 students who are requesting course changes, whose last names begin with the letters G to M, with teacher's permission, please report to the counseling center. That's grade 12s only. Last names G to M. Thank you.
Okay, so cube root of 70. What's a cube root that's below it that we know? We talked about it a little bit. Cube root of 27. Oh no, cube root of 64, I believe. That equals what? 4. So what number is above 4? 5. See how I'm working backwards now? Right? Number higher than 4 is 5. And so what's the perfect cube of 5? 5 times 5 times 5? 125. Okay. So I'm filling in the puzzle, working backwards. We should have done this last year. Hopefully we did. Okay. So now we're looking at this one. 70. Am I really close to 64? Or am I really close to 125? Yeah, I'm close to 64. So what do you think we should have as our decimal? 4 point. Let's go. Jenna, what do you think? I mean, really close, so it can't be 4.5, right? It's got to be more. 4.2, perfect. 4.1 I'd even probably take. For a cube, it's not very accurate, okay? But sure, let's go 4.2. What about this next one? Cube root of 30. What's a perfect cube below 30? What's a perfect cube above 30? I know one below. Anyone else? Caleb, any ideas? 2 cubed is 8. 3 cubed is... I was going to say Nicole. Jenna? Sorry. Any ideas? 27. Right? We've talked about this 27 number a bit. What is that? Cube root of 27? 3 times 3 times 3. Okay. So I'm just doing the stuff on my head, right? 3 cubed. Now you're going to start memorizing this because this is how many times have we seen this now? Today? 4 times. Right? So it's the same stuff over and over. So this has to be a 4, and that would be then 64. Okay. So what do you think the approximation of cube root 30 is? Jackie, what do you think? Oh, we're really close to the 3. No, 3.3 is close to the middle. We're so close, I'd say 3.1. Okay, so close. Okay. Let's try this one. Now, it's very inaccurate once your index gets up to 4. So what's, 4? Any ideas? A 4th root. Well, what's the 4th root of, what's 1 times 1 times 1? 1. The 4th root of 1 equals 1. What number is above 1? 2. Okay. So what's 2 times 2 times 2 times 2? Cody? 2 times 2 is 4, times 2 is 8, times 2 is 16. Good. Okay. So we'd be looking at the 4th root of 16. Okay. So looking here then, what's the estimation? Here we are 5 digits away. Here we are 10 digits away. So what's your estimation? Tyus, what do you think? Perfect. Yeah, I like that. 1.3, 1.4, 1.2 probably. Definitely not 1.5 because look, 10 and 5, those aren't the same. If it's in the middle, the difference of the digits would be the same. Okay. Good. So now we can put on a number line. We got 5.7. We have 4.2. We got a 3.1. We got a 1.3. So let's call this a 0. 1, 2, 3, 4, 5, 6, 7. Good. Okay, put them on there where you think they belong. Go for it. Number on a number line. Remember, 0.5 is right in the middle, so it's all they got. Okay, so you got to put it in roughly the right correct spot. So 1.3 is E, so I'd put E right here. Okay, so this is where I'm going to put E. In between the 1 and the 2, but not in the middle, a little bit closer to the 1. Okay. What about 3.D? D, where should you put D? D is 3.1, so I'd put D right here. D's got to be really close to the 3. Okay, really close to the 3. Now C and A are exactly the same, so they'll go in the same spot. So that's 5.7. So I would put that right here. A and C. So I'm not at 5.5, folks. Absolutely not at 5.5. You got to make sure you're not there. I'm a little bit closer to the 6. Okay. And the last one is B, cube root of 70, 4.2. I'm going to be just a little bit above the 4. And so there's B. Okay. In between the 4 and the 5, but closer, a lot closer to the 4. Any questions about number lines? It does matter, folks. If it's in the middle and it's not 3.5, I'm marking it wrong. Okay? Good. So now we've covered everything. Some of your homework